Okay, let's start then. We have a permission for takeoff. So welcome to the second and last installment of the conceptual series that have to do with using Pharo in a corporate environment. This talk is entitled Guerrilla IT with Pharo. To some extent, it looks at the same problematic as I discussed in my first talk on the first day, but does it from a different angle and with different objectives in mind. First thing first, clarifications, right? I want to make sure that everybody understands that Guerilla IT is just a metaphor. And I use it for some specific aims to communicate a given experience when using Pharo in enterprise environment. It doesn't really have anything to do with kind of military applications. Well, you have kind of the clarification at the top. Unfortunately, at the bottom, there is a part that you cannot see. So I just read it. The Guerilla in IT metaphor brings out some facets of the situation you are likely to find yourself in when using Pharo in an enterprise setting, at least from my perspective and in my experience. And this setting has inherent challenges. In some cases, mitigation could be attempted using Pharo. Sometimes it should not. There are better means for the mitigation. In some other cases, it could be attempted fruitfully. I'm going to talk a bit about both categories, hence the title Guerilla IT with Pharo. So let's move on to the overview of the talk. What is that I'm going to talk about? So first I'm going to develop a metaphor. I like metaphors. And there are some metaphors that I like more than others. I like the metaphor of Guerilla with Pharo more than some other excellent metaphors, like agile or things like that. Then I'm going to talk about key challenges and talk about requirements and requirements management and traceability in context of using Pharo. And then I will talk about some samples. They won't be that different from the things that I talked about on the first day, but I'm going to talk about them in a slightly different perspective, more perhaps from the perspective of kind of the concrete, the actual practical experience. And there will be also time for conclusions at the end. So let's start. All right. What is Guerilla? There is some standard definition of what that is, but I am mainly interested in some elements of the concept in order to build a metaphor that is usable or potentially useful for communicating the experience of using Pharo in enterprise context. So the notion of asymmetry is important here. Now the other interesting piece is that in the notion of Guerilla, there are two distinct viewpoints. One is descriptive, the other one is prescriptive. Descriptive is when Guerilla is taken as something that characterizes the existing situation, the status quo. Right? So, existing asymmetry in strength, contrasting the impacts of failure on respective sides. Right? If you are a small operator working in enterprise context, then the consequences of your failure on the enterprise are almost non-existent, but they may be very important for you, right? So that's another aspect of asymmetry there. And there are some actual differences in strategy and tactics. right? For example, the ones that are expressed in different approaches to how software is built and how management is done, the corporate project management culture and stuff like that. So I won't talk much about that, mainly out of politeness. The prescriptive part of it is about the strategy element in Guerilla. Right? What are the goals of applying Guerilla as a form of warfare in general, the source concept? So, two important aspects of interest are first that we want to magnify the impact of the small force, right? Presumably the one that introduces or works with Pharo. And the second one is to not simply to defeat an enemy, but also to win popular support. So, again, those two elements, descriptive and prescriptive, are useful for the metaphor. All right. Now, what is Guerilla in IT concept or metaphor means? Well, in IT. So, as a strategy description, what it means is that we want to drive the solution rather than wait for the solution to happen. It means that you need to assume broad software development lifecycle responsibilities. You want to be open to non-conventional solutions and so forth. On the status quo description side, you have this standard characterization of small and tiny teams, short time frames, dealing with defective kind of environment in many ways, things of that kind. So that slide talks about how the strategy, the prescriptive part of the Guerilla concept, and how the descriptive side of the Guerilla concept kind of express themselves in IT environment. Any questions so far? I hope not. Okay. So now, key challenges in enterprise setting. I kind of claim that there are two. One has to do with requirements, the other one has with feasibility. And perhaps I should quickly recount a story that helps understand, one, there are only two of them, and why they are what they are. So, when I went to high school, admittedly it was a very long time ago, I had mandatory Russian, I had mandatory English, and for extra credit I took also French. And French teachers, being French, they sometimes give you strange home assignments. So, on one occasion I got an assignment for an essay that said something, what are the two most important events in your life, and kind of describe them. So I gave it a serious thought because I like the teacher a lot. And I came up with an answer that seemed interesting to me, but unfortunately it was summed up in something like 4 or 5 sentences. So the answer was that obviously for everyone, there are only 2 events in our lives that everybody can agree on. One is the moment of birth, the other one is the moment of death. Unfortunately, there is not much I can say about either of them, right? Because birth, well, it did happen, but I don't remember anything. And the death, well, it didn't happen yet, so there is nothing to say about it much. So I kind of put it in, and after a while I got a grading. It was B, like bien. And it was really surprising because I could understand insuffisant, which is like failure, or, très bien, A. Well, B, it was kind of strange, but this is how it was. So the analogy with this kind of situation is that I would argue that requirements and traceability are a bit like the birth and death as 2 most important events, in the sense that requirements is the logical beginning of a development life cycle. And traceability, at least in one of the understanding of the terms is something that is required in order to make the first step and then other steps, right? So if the foundation, the starting point is screwed up, then basically we have a kind of doom looming on the horizon. Similarly, if we make missteps in any direction, the probability of failure and risk of failure kind of goes sky high. So that's the kind of mental picture behind claiming that those two are the key challenges in enterprise setting, and because there are, at least in my view, and now you know for what reason, there are key challenges in enterprise setting, I want to relate to them when using Pharo in this type of environment, because the idea is that if you want to use Pharo sensibly outside just of kind of construction and testing lifecycle, then you have also to face those two issues. That is the issue of requirements of the management in some way, even if fractionally, and also of traceability. Now, I also realize that, well, requirements like requirements, but traceability is not necessarily something popular in our culture. And there will be some reasons kind of to talk about it in a moment. Okay, so let's talk for a moment about meanings of traceability. The three main meanings that I'm familiar with are those shown on the slide. There is a narrow meaning that is most common. There is kind of broader meaning, and there is academic meaning, which is probably the most interesting one. The narrow meaning always has to do with testing. So narrow meaning of traceability is just about linking together, tracing, testing artifacts back to requirements, right? And the objective, not only from purely logical standpoint, but also usually contractual standpoint, is to prove that all the requirements have been implemented. Secondly, they have been successfully implemented, right? So this is kind of the narrow notion of traceability. A broader meaning, like in IEEE definitions, broadens the concept away from a specific testing context to basically a relationship between any artifacts of any kind within the software lifecycle, any work product in general. Now, the kind of academic abstract idea is basically that traceability has to do with linking together different kinds of models using well-defined model transformations, right? So you start with something like requirements model, then you do some transformations of the model and you come up with kind of design model, and then from that you have some execution model, kind of testing model and stuff like that, right? So that's yet another idea. There is a common thread in them, that is the notion that you go from square A to square B in some sensible way, and you can describe how you did it, right, in a sense. So far, so good? Now let's talk for a moment about manifestations of traceability, and one observation is that in different contexts, those different meanings of traceability manifest themselves in a slightly different way. So what I'm trying to do here is to bring up the difference between how traceability typically functions in software projects in the large, meaning kind of enterprise stuff, large scale, large budgets, and whatever, and also how it manifests itself in the small, right? So there are some typical scenarios in the large. That is, traceability is rarely absent, but if it's absent, it's usually an indication of a deficient contractual language. Because usually any sensible contract in a project in the large will contain traceability clauses. Now, if things go okay, then traceability is typically paid lip service, right? That is, okay, we know it's there, but nobody does anything about it, right? It may be a deliverable, but in fact, it doesn't affect anything, anything tangible, at least. Now, when traceability starts to show up is when things start going bad, right? It becomes antagonistic in the sense that the vendor or service provider claims one thing, the customer claims some other thing, and they start tracing the artifacts that have been produced, tested or not tested or mistested back to requirements and contractual language. Then you have this next stage, I call it nuclear fusion, and it usually happens when litigation is looming on the horizon. Now, in almost all of those cases, in projects kind of in the large, traceability is kind of backward-looking artifact. It's kind of reactive, right? So that's one of the interesting features of it. Now, with traceability in the small, we have a shorter list, mainly because by default, traceability, when kind of taken in the context of small projects, is virtually absent. Right? Because of many reasons. People don't want to be bothered, there is not enough time, there is not enough money, there are no, many things are kind of lacking or missing to kind of make it appearance. And that's probably not a good thing. Because even in context of a small operation, traceability is pretty critical, both from the legal perspective and the operational perspective, increasing the chances of success even in a small project. However, at the same time, almost everybody understands that maintaining traceability involves an overhead that cannot be sustained, right? Because there are other things to do, and traceability is not at the top of the priority list. So, of course, at some stage it may become antagonistic and backward-looking, just like in the standard scenario. I would even claim that this is standard development in the evolution of traceability, right? At the beginning it's absent, or, paid lip service, and only when things go wrong, and reportedly 95% or more of software projects, large software projects, things do go wrong, then it becomes visible. So what I'm interested in this context is a notion that goes against a typical manifestation of traceability in projects in the large, that is not antagonistic and backward-looking, but rather something that is collaborative and forward-looking. Right? So I'll try in a few slides' time to provide a suggestion, kind of example of how one could go about it using Pharo, using Smalltalk in general. I'm talking again about Pharo because I used Pharo, and that's the specific context of the experiences I'm talking about. Any questions so far? You are still with me? Yeah. Okay.
Yes.
All right, so now we are leaving this nebulous area of the metaphor more towards the concrete of using Pharo, right, in this Guerilla. So the guiding questions here are listed. Can Pharo be used outside its usual place as a construction testing toolkit, right, in a software development lifecycle? Well, obviously, yes. Can it be used to mitigate the requirements predicament, right? Yes, with some limitations, but at least it can be used. It cannot be used to solve all the problems, but it can be used to solve or mitigate at least some problems. Can it be used to help establishing a collaborative, forward-looking traceability? And again, the answer is yes. Some things can be done, and I will talk in a minute about what can be done in practice. But before I go there, I want to address the question how all of that, yes thing is even possible. So, in my view, the difference between things like Pharo and the mainstream is kind of a derivation of the productivity and kind of power of the environment and combined power of all the components that you can bring to work within the environment. So in the mainstream, the overhead with moving through different life cycle kind of steps is so big that it makes it generally unthinkable and impractical to use the tools being used for the target project in order to provide some kind of assistive tooling or help or something useful within the project itself, right? Usually it doesn't happen, right? If you deal with a large-scale Java project, right, nobody would really talk about using the same technology in order to kind of advance the work within the project itself. It just doesn't come up. It is something nonsensical to do. If it were the case, then there would be a separate bid and separate contract on making it happen, and so forth ad infinitum. Now, the difference with Pharo, in my experience at least, is that this low cost and high speed of building, let's say assistive tooling, makes using Pharo to support this guerrilla strategy. And I will remind you, right, to go back to this slide, or mentally to this slide, with what guerrilla strategy is, right, to kind of maximize the impact and win popular support. So it makes supporting this guerrilla strategy conceivable and feasible in practice. Now, it's kind of interesting that in practice one discovers that sometimes even very simple, perhaps not trivial, but simple forms of that assistive tooling and some reasonable practices that are brought on the back of those simple tools can produce surprisingly kind of good return in terms of making the collaboration and advancements better compared to kind of the standard mainstream practices. So far so good? Any questions? Okay. All right, so before we go to the examples, some rules of thumb as to what are the promising ways of introducing simple low-cost improvements that have high impact potential. Well, that should be a bullet point, the first one, right? So one rule of thumb is go for simple low-cost improvements that have high impact potential. So with respect to dealing with requirements problems, it usually has to do first in some form of transforming the default or the starting representation of data information that together make the requirements. To give you a somewhat trivial example, in many organizations the default format of representing anything is Excel spreadsheets, right? Which is pretty horrible. And actually, this is one of the reasons I don't really have much to do, much against Excel when used within its intended area of application, but when it's used outside of this intended area, for example, for representing and collecting requirements, the outcomes are not very good, and that kind of brought me to maintain on occasion that Excel is basically the second biggest disaster in 19th, 20th century. You may wonder what the first one is, right? C++. Okay, so once you transform this representation, then the idea is to make this form accessible and easy to transform, right? Also, when this information changes, make generation of updated information kind of trivial and simple, so it can be shared, and so that you can inverse the typical relationship. That is, you basically have a notion of a model that contains the model of requirements in some way, and you generate documentation from it, rather than everybody tries to construct in their heads, and typically failing, construct in their head some mental model of those requirements, starting from some documents that often are completely not digestible or not good to process or not easy to process. All right, so some other rules of thumb is things to avoid. Well, it doesn't really make sense to try and fix in enterprise context things that cannot easily be fixed. And there are many. Also, in practice, it doesn't make sense to try to replicate even a good assistive function if it can be replicated or supported at much lower cost, because, for example, some open source software stuff already exists. And the case in point is ESUG tracking systems. Right? One of the things that I would typically insist on at the beginning of this kind of Guerilla type project, involving Pharo or not involving Pharo, is to set up an ESUG tracking system in cases, and often this is the case, when it doesn't exist. Right? And you can do that like within half an hour or something, incurring almost zero cost. So that would be an example of a thing that it's impractical to do in this kind of context of using Pharo. If you have bandwidth and you want to create either an interface to an existing ESUG tracking system or build a tracking system, fine, but most of the time it's not economically justifiable. Another one is to avoid, providing functions with low impact potential, right? I know the lure, because quite often they may be very sexy and very cool, but by the end of the day, they do not really impact the baseline that much.
Question?
Yes?
So about the last point, how can you estimate or imagine that there's low impact? Maybe some little gadget which is seemingly unimportant might make a big difference in the future. So you're kind of closed in your perspective when you avoid these things.
Well, the question is, how can I know whether something is low potential or not? Well, effectively, I don't know. Right? It's almost like a question of whether God exists and what to do with that. There are kind of two approaches to it. One is the Pascal's bet, right? That is, even though I don't know, it pays for me to assume that the God exists. So, applied to this particular question, one approach would be, although I don't know if there will be a payback, it still makes sense to implement a given solution because the payback may happen. But unfortunately, most of this stuff happens within very limited time frames and with limited constraints. So the burden of proof switches on someone kind of proposing the solution, right? That is, if you cannot see clearly the possibility of the payback within the time frame in which you are operating, then it's basically your effective criterion of elimination things that are not likely to work for you. Right? So the criterion is kind of pragmatic in a sense, right? You cannot think of it, you don't really see it, oh well, you don't do that. Right? maybe someone else can see that and they can convince you that it's sensible to do, yeah, we can have conversation about it and whatever, right? But by default, this is the criteria. Does it answer the question?
Yes.
Okay. Your question, sir? No? Good question? I'm disappointed. Okay. So now let's go to real-life examples. So the first thing is dealing with kind of requirements. And here I'm not claiming that this type of approach is capable of dealing with all the problems with requirements, but at least some problems with requirements. And what I have experienced myself is that this is kind of promising that in practice can bring up the consequences in the lower half of the screen. So it's repeating what I said in the slide with rules of thumb, transforming the requirements away from the typical inedible forms, republish them in digestible and easy to access form. For example, website portal provides simple query reporting capabilities, show people that this is easier for them, sometimes fun. And interestingly, with tools like Pharo, it's very easy to do. Right? We have Seaside and extensions to it. It doesn't really take a long time to set it up. It doesn't really take a very long time to create some kind of sensible object model and visualize it in a kind of web-friendly way. It's not that difficult to provide, at least for simple query facilities and downloading of some selected information of interest, for the end users. Now, we have to remember that all of that is in the context of being assistive in the project outside of the design, construction, and testing proper. That is the main kind of contractual goal of the engagement. So what we get there, we can get better traction with non-tech people, better external visibility of the tech issues, because if you look in a complex enough Excel spreadsheet, I guarantee you won't see anything. Then you get more eyeballs, better coverage, better quality, and so forth. So a simple thing like that also introduces some opportunities. One of them is the opportunity for introducing some kind of standardization corrections relatively easily and painlessly. Right? Usually when people start doing things in a way that doesn't make logical sense, it's pretty difficult to fix it. But if you provide some, let's say, assistive tools of that kind, then it becomes much easier because you can hide this correction behind the tooling. So you can check for some typical or frequent types of logical errors that happen in even grouping, naming, or describing, let's say, requirements kind of behind the scenes and tell the user, no, it's rather you should do it that way or some other way. It's not that difficult to do. The other not so obvious opportunities is that you can also divide and conquer through the use or adoption of those kind of assistive things. That is, you can partition a big chunk of stuff that is normally very difficult to process in its entirety into smaller chunks and kind of delegate it to people who eventually, or you hope, will assume ownership of those chunks, and then collaboration on those chunks will happen in a non-blocking way, right? That is somewhat asynchronously, to use the comparison there, right? And it speeds up the process. Any questions about this one? Oh, okay.
Yeah.
Yes?
this might be a question for the end, but I will ask it now. Do you have any practical examples that you could show us in code or share?
Yeah, that's the one. I mean, you've seen a similar slide, a very similar slide before, but now I'm going to talk about it from the point of view of the previous thing. So in the background, it's an actual example from actual project. What you have is a statement of kind of requirements, functional kind of know-how that is originally expressed in Excel, this huge Excel spreadsheet, and nobody really understands what it says. So using, I hope I didn't mangle the name Cytoscape. It is telescope plus web, right? That's the right name, Cytoscape or something similar, right? And by creating some simple object model for expressing the kind of the structure of the corpus in this case, which is just another name or kind of instantiation of a notion of a requirements model. And that you see that in the middle, right? This kind of a dump from kind of GitHub filing of the project. So it gives you kind of a quick view of the classes. It's not very complicated, and you can also see that the elements that come from Cytoscape and telescope there. So the idea was first to transform, right, the format of the data from something that is not digestible into something that is digestible, that is usable, right? So this is how you get, in the first instance, something that is capable of showing to the users some logical errors with the existing spec, and it enables them to navigate and understand what is they are dealing with, right? So in blue, you have the outcome of processing of this data, or requirements, representation of requirements in the original form into something that is kind of digestible and usable. And then suddenly all those SMEs, subject matter experts, right, they say, oh, okay, now I understand. Yeah, you're right, it doesn't really make sense, to have this type of arrangements, and there should be a better way of organizing it. And then you can propose a better way of organizing it, which is here in green, and tell them, okay, so now you have tools to understand what it is, and it is easier for you to propose a structure that makes sense in the long term, because specifically in this type of projects that have to do with knowledge base maintenance, the main long-term effort and cost goes into the maintenance of the knowledge base, not in the technology, right? So if we can start doing that in a sensible way, then the chances of long-term success will increase. Okay, so does it answer your request? It's an example, it's a modest example, but still it's an example. Okay, it kind of opens a way, it doesn't really walk that kind of road very far, but at least it starts working. Okay. Now the kind of implementational overhead was like 1 weekend, to do that stuff, and the payback was pretty significant. Right? This is basically make a difference between having to fight for weeks with something that was very painful to deal with, into a form that suddenly created some traction with non-technical people who started thinking about their requirements, in a somewhat more rigorous way. So that's the point. Right? Okay, so the second example has to do with kind of moving towards better traceability, and by better traceability I mean this collaborative rather than antagonistic, and forward-looking rather than backward-looking variety of traceability. So in this case, a kind of the set of steps or the approach, kind of tactics on the side of using Pharo specifically in this case, was to deal with requirements that changed effectively every day, and they had to do with constraints on data to be validated, not only with format, but also the rules of validation, right? So in space of probably a year, in kind of 3 different sub-projects, there were 1,200 recorded change requests. And not all requests that were change requests were recorded, right? So it gives you kind of an idea of the volume and volatility of the changes. So when you are faced with that situation and you understand the dynamics and the fact that it won't go away by itself, the defensive measure is to come up with some form of design that can handle this type of situation, right? So one form is to build some form of DSL that will express the requirements, in this case, specific logical business rules that specify what the thing is expected to do, or more from kind of design point of view, implement some form of interpreter path in which you isolate a representation kind of the rules and the execution of those rules, right? So that the rules themselves, just like a text of a programming language, can change relatively easily and quickly, but the underlying engine of interpreting, right, the specification remains the same, right? This is one way of retaining sanity in a situation where your requirements change every day, or pretty often, at least for the first half of the project, or something like that, right? So there are some consequences of that type of approach on the practical side. First, somewhat unexpected outcome was that building this kind of approach, even before it is fully implemented, gives you a way of first early and easy validation of requirements, at least with respect to business rules and kind of logic that is to be employed. And second, it also provides you with a form of traceability that is understandable for the non-technical users. And they understand that, or they start understanding that when they change the spec, it will have impacts on the behavior of the system. And usually, this is not widely understood by people who formulate requirements. So we have this early pre-construction and pre-testing validation of some types of requirements, some of them kind of crucial ones. And the important point here is that some of this initial early validation of requirements or some form of conceptual testing can effectively impact your design decisions. So it is really in your interest to bring up those types of semi-formalized or better description of business rules or of requirements in order to protect yourself and in order to face some of the risk and some decisions as early as possible. So what are the opportunities, right? The opportunities are to introduce improved precision and cohesion of the language that is used to describe the requirements, or especially business rules. That's notoriously difficult area to kind of get through with people with no, say, formal logic training or no habits of relatively kind of precise thinking about things. And again, divide and conquer and introduction of ownership and accountability, things of that kind. Better understanding of how things work. And this helps establish what I was hoping for, that is some form of better traceability, meaning the one that is collaborative, not antagonistic. This is kind of our common understanding, and within it we can kind of do better, and also forward-looking because it tries to avoid some things and specify some things as soon as possible, rather than only bring them up, 10 minutes? Oh, that's fine, we are pretty close. Not to bring them up in face of kind of dooming or looming litigation. All right, so let's have a look at the example here. So what you see here is, the inspector in the background. That's an inspector on set of instances of kind of complex business rules. You can see on the right-hand side there is kind of partial view of precondition, all those kind of things that I cannot show you. But there are, a number of rules. And the point is that if you make them intelligent enough to represent themselves in a way that is digestible to end users, that is non-technical users, then you are already in game, right? That is, you can generate those textual renderings or textual self-renderings rather than self-textual renderings, and give them to people who formulated those requirements in the first place and ask them, okay, is it that the logic that you actually meant? Right? And that already in itself is a big practical step compared to, you may recall in the previous slide in the background, this kind of huge Excel, right? People look at and it's very difficult to figure out what it really means, not to speak of correctness of what supposedly it means. So some of this stuff is kind of complicated. Those two examples show you the kind of level of implicit complexity of the rules. They are not necessarily trivial. And there is an element of some kind of DSL-ish type of approach when the textual self-rendering of a rule can produce kind of abbreviations in terms of, a value in a given field is none of case insensitive, whatever, right? Things of that kind. Or a given row has at least one value, right? It's not really how the logical condition works at the level of implementation, right? But this type of representation works for end users, right? The people who work with those types of requirements. You won't tell them, a very long kind of conjunction or combination of conjunction alternative kind of trees or something, or conditions. You have to provide them with something simple, right? Something like row has at least one value in those fields, right? They can understand it. Right? So again, this is a simple example. It's not something very complicated. It doesn't take very long time to have it implemented even by one person, although it takes some kind of thinking and some, surge of inspiration and self-motivation to do it. But once it is done, it provides surprisingly good outcomes. Right? It gives one a tangible and relatively rigorous expression of the business rules that are implemented in the system, and if there are problems with kind of testing and functional testing, you can always go back to those and say, well, in the test you say, you expect this and this and this, but you agreed 2 months ago that this is the proper rule, and this is the rule, how it works, so what do you want, right? It kind of makes things easier. Okay? Okay. Any questions about that? All right, so last these are kind of conclusions. I've been talking about this guerrilla metaphor because it seems to me that it may be helpful to people. So it may help you relate to real life experiences, help you consider what actual tangible agile can mean when the die hits the road, and it may also help kind of stimulate thinking along those lines in your own projects. If I wanted to sum up the main thought that I was trying to play with, is that low cost and high speed of building those assistive tools makes using Pharo to support the guerrilla strategy conceivable and feasible. That's probably the main thought. And also that some types of this assistive tooling give you disproportionately positive kind of return on investment, right? In managerial terms, so give you a good outcome. So now going back to the initial slide when I said that the metaphor of Guerilla in IT doesn't have much to do with the idea of war, right? I was saying that this metaphor emphasizes two things, that is descriptive and prescriptive aspects of it. I'd like to close this with saying that even though this metaphor is not about military operations, in some sense it's also a call to arms. Right? That is, well, there are some things you can do to make your life better in even complex projects if you bring into the equation, those types of tools and solutions. This doesn't give you recipes for all the situations, but it shows you what can be done and you can build on that. Okay, thank you. I'll take questions.